Find all solutions for this equation algebraically. Now, I'm going to review a lot of what we've done thus far. What I strongly recommend is you need to watch this until you understand what I've done. There's a lot going on. So, our step 1, solve for the trig function. So we're going to try to get the either sine, cosine, tangent, whatever it is, in this case sine. We're going to get that by itself. So we'll divide by -4, and we get sine of 3x equals 2 divided by -4 is -1/2. At this point, we've isolated the trig, so we're going to go to our unit circle. This is sine is a y value on the unit circle, y equals -1/2. We can see that there are two solutions here, but we have to be careful here because doesn't say theta, or doesn't say just x, it says 3x. So what we're going to do here is say, all right, what are these two solutions first? This one in the third quadrant will be 7 pi over 6. Leave some space here. Or 3x equals 11 pi over 6. Now, why do I want you to leave space? Because this problem is not a regular sine graph. What does this 3 do to the graph? Remember, what does that 3 mean? It means we have 3 complete cycles in one normal periods of 2 pi. And so what we have to do here is we have to say plus 2 pi n. Now some might say, but wait, we're only solving between 0 to 2 pi. That is true, but we're going to have to deal with this 3, and what's that going to do to the period? Since we have 3 complete cycles, the period is now shorter than 2 pi. Now we're going to divide by 3, but I would strongly recommend instead of dividing by 3, we multiply by the reciprocal, because too often people make mistakes with dividing a fraction by 3. And we get x equals 7 pi over 18 plus 2 pi over 3 times n. Similarly, we'll do the same thing over here. Let's multiply by a third. So we get x equals 11 pi over 18 plus 2 pi over 3 times n. Notice that we're not really, when we solve for x, we're not adding 2 pi, but we're adding 2 pi over 3 because the period of the function has been changed. The period of this trig function has been changed, and we'll show that with a graph in just a second. Now, what I would say to do is take this 18, see how we have 18 there? We want to make this have an 18. It'll make the writing the solutions easier. So we have 7 pi over 18 plus, multiply the top and bottom by 6, so we have 12 pi over 18, and we do the same thing on the other one. 11 pi over 18 plus 12 pi over 18. n. Now we can start listing the solutions out. The first one will be 7 pi over 18. That's if n is 0. What if n is 1? Well, then we'd have 7 pi over 18 plus 12 pi over 18, and we'd get 19 pi over 18. What if n is 2? Then we're adding another 12 pi over 18. You could either say 24 pi over 18 plus 7 pi over 18, or we're just going to add another period of 12 pi over 18 to the 19 pi over 18, and we get 31 pi over 18. If we add another 12 pi, we get 43 pi over 18. Now my question for you is, how do we know where to stop? Think about that. We have this restricted domain here, 0 to 2 pi, excuse me. So do all of these fit in that domain? No, 43 over 18 is bigger than 2. In other words, when we get bigger than 36 or bigger, that is not going to be a part of our solution, so we don't include that. And on this piece, we have 11 pi over 18, add 12 pi over 18 to get 23 pi over 18, add another 12 pi to get 35 pi over 18, and you can see if we add another 12, we'll get 47 pi over 18, and that's bigger than our 36 pi over 18, so we don't include it. So look at the number of solutions we have. We have 6 solutions, 3 from each part. Now let's take a look at what this would be if we graphed it. Let's graph over here. Let's see. And we're going to go 4 to -4. So what we're going to do right now is graph y equals -4 sine of 3x, and then we'll graph y equals 2. So what's the 4 mean? That's our amplitude would be 4. It's going to stretch the sine graph up to 4 and down to -4. Sine normally starts by going up, so the -4 means it'll go down. And then the 3 means we're going to have 3 complete cycles. There's 1, 2, 3. And it's not perfect, but that's okay. What I want to do right for this stuff is really to have a sketch. Now, what is this number right here? In other words, what is the period of the function? We have 3 periods equal 2 pi, so the period here is 2 pi over 3. So if this one is 2 pi over 3, one more period would be 4 pi over 3. One more period would be 6 pi over 3, which reduces to 2 pi. Now we can sketch the graph of y equals 2. And we can see how many solutions do we have. 1, 2, 3, 4, 5, 6. And those correspond to what we found algebraically. Now let's take a look at these. What is this one? Well, if this one period is 2 pi over 3, this one will be pi over 3. This will be pi over 6, 2 pi over 6, 3 pi over 6, which will reduce to pi over 2. The only reason I'm going through this part right now, my focus isn't the graph, but it's to see where do these numbers lie. So if we put this over 18, this would be 6 pi over 18, and this would be 9 pi over 18. And 7 pi over 18 is something in between. Now, where's 19 pi? Well, we add the period to it. This one will be 19 pi over 18. Add another period, and we get 31 pi over 18. So these 3 with the circles on them correspond to our first 3 solutions. If I take a look at the next one, that would be 11 pi over 18. Add 2 pi over 3, and we get 23 pi over 18. Add 2 pi over 3 again, and we get 35 pi over 18. So we get all 6 solutions. Notice that process. Since our period was changed, we're going to say whatever this angle was equals what we found from the unit circle plus 2 pi n, and then we go through, solve for the x, and start writing out all the solutions until we get past 2 pi. Okay, this one's a little review problem. What's the period here? I want to write the equation of this. What is the period? The period here is 6 pi. It asks for that here. The amplitude will just be 2. We can see that since it's symmetric about the x-axis. Now, what trig function is this? This will be sine. So sine is starting at our midline, starting in the middle. We need to find out what b is. b times 6 pi equals 2 pi. So b would be 2 pi over 6 pi, or in other words, 1/3. Since it's sine, we have the c value. We don't need it, so we can say c is 0. And this wasn't shifted at all, so the d value would be 0. It's symmetric about that x-axis. So our equation here is y equals 2 sine of 1/3 x. Okay, now let's take a look at the next one. This one, you should notice, is very similar to it. We can draw that line in, and we have the period here again is 6 pi. The amplitude again is 2. Let me rewrite that. We have a value, or we did the a value. We have a b value. It's going to be the same as what we just found over here. Now what's different about this graph? This whole graph was shifted up. So our d value is going to be the average of these two numbers. Because it's the midline. D gives us that middle line. So it's 3 plus -1 divided by 2, which is 2 over 2, or 1. And so this equation becomes 2 sine 1/3 x, and then all of that plus 1. So the only thing that one really does is adds this d, because we didn't have that in the last one. Here's a couple practice problems for solving, similar to what we did in problem number 1. In fact, what I want you to do right now is go back to the top of the page and say, circle number 1 and say, important, know this problem. So just like in problem number 1, we're going to take this and we're going to isolate the trig function. So we have cosine of pi over 4x equals -1/3. What do you notice about this problem versus the problem number 1? This one is not a unit circle value, whereas in the first one we had -1/2 was. We're still going to use a unit circle because we want to see how many solutions there are here, and we can see that there are 2 here. Remember, cosine is x, so x equals -1/3. Now what we're going to do is we solve for this, so pi over 4x equals the arc cosine of -1/3. And we're going to type that in on your calculator. I did it here. See if you can get that to show up. So we have pi over 4x is approximately equal to 1.91. And remember, just like the first one, the period's been changed, so we're going to say plus 2 pi n. Or pi over 4x is approximately equal to, we need to get this other angle. Do you remember how to get that? That's where we're going to say 2. Oh, but before I do this, I forgot, I need to show you how to, and I've used the memory before, but I need to show you this again. So below, right next to the 1 key, there's this button STO. Press it, and it shows answer, arrow, and then type in alpha A. And so what we're going to do is place this into the spot A. Now what's going to happen is we're going to say, I'm going to figure out what this other angle is, which is 2 pi minus, and I can just say second answer, or I can say alpha A, and I get this 4.37 plus 2 pi n. Now we need to solve this, so what we're going to do is say multiply both sides by 4 over pi. And we're going to do it to both of these. So we're going to say 4 over pi, 4 over pi, 4 over pi. What happens on this one? The pi's reduce out and we're left with 8. So we'll have 8n. And then we're going to do the same thing on the other side. And so we'll have something plus 8n. And what I'm going to do right now, since this 4.37 number is on my screen, I'm going to use that one first. So I'm just going to hit times 4 divided by pi. And I get 5.57. Now I need to do the same thing to the previous one, but that was in A. So I'm going to say alpha A times 4 divided by pi. And I'll get 2.43. So now we're going to start listing out our answers. We know we have 2.43. That's a number that's in between 0 and pi, or 0 and 2 pi. If I add 8 to it, does that stay between 0 and 2 pi? No, because 8 is more than 2 pi. 2 pi is only 6.28 approximately. So we can't add 8. What if I subtract it? I would have a negative number. That doesn't work as well. I only have one solution from this. Similarly, I'll get 5.57, but if I add 8, I'm outside of my domain 0 to 2 pi. That's not going to work. And if I subtract it, it'll be negative. That won't work. So in this particular one, I only have the 2 solutions, but I need to make sure I've included that 2 pi n and check to see that it does work. Let's take a look at the next one. I'll clear the screen. So we're going to isolate the sign first, divide by 2.5, or this is the same as 5 over 2. So if we multiply by 2 over 5, we get 4 over 5. Look at our handy-dandy circle. Sign is y. Y equals 0.8. 4/5 is up here, so there's going to be 2 answers. So I'm going to take out my calculator. I have inverse sine of 4 over 5, or 0.8, and I get 0.927. So I'm going to have x over 2 is approximately equal to 0.93. Now I'm going to write 3 on my paper, but I'm going to keep this number on the calculator, plus 2 pi n. Or, now before I go to this or part, let's take this and store it into a letter. If you want to keep the previous one we had an A, let's say I want to keep that there, so I'll hit stow alpha D. I tend to like to do these first letters over there. Now I could say over here that D is 0.93, kind of in a little thinking bubble here. So I have that. That's secure now. Now I need to get this other angle. Remember, here's pi. This angle is 0.93, so it's going to be pi minus 0.93. So I'll get x over 2 is approximately equal to, so let me go pi minus answer. And I get 2.21 plus 2 pi n. Take again, and we'll have x over 2. So we're going to multiply both sides by 2 on both of these. So since this last one's up, I'll just deal with that. I'll say times 2, and I get 4.43. I almost made a mistake there. 4.43 plus 4 pi n. And on the other one, I will say alpha d this time times 2, and I get 1.85. Now, in terms of the rest of this, what I really did is I kind of blew this. And the reason why I did that, or that this is a mistake, is I should have continued with this one completely before I went back to deal with this first set of numbers. But that's okay in this particular problem, because when we add 4 pi, we're not going to get an extra solution again. And over here, we add 4 pi, we're not going to, because we're going to be outside our domain. So again, we have another problem where we only have 2 solutions. And that's it for this. I will post up another video for the 4b, which is going to be a challenging version. I'm going to change one number on here, and I'm going to put a negative in there, and it will make everything much harder. But you can take a look at that after you're confident on knowing what to do on these ones.